On the surface, it resembles a complex typewriter, but its inner workings created a code thought to be unbreakable. Its operation began here, at the keyboard, where an operator would type the plaintext message.
Plugboard, rotors, and lamp board. Together, these components created what was believed to be an unbreakable code.
Before a signal even reaches the rotors, it must pass through the first layer of randomization, the plugboard.
Known as the Steckerbrett, its function was simple but powerful: to swap pairs of letters before they entered the main scrambling unit.
This was achieved by connecting pairs of sockets using these double-ended cables, creating a series of simple electrical swaps. And the other end to S, the two letters would be electrically swapped for the duration of the message. Now, when the operator presses the A key,
this swapped signal, now effectively an S, is what enters the main scrambling unit, the rotors.
At the heart of the Enigma are 3, and later more, interchangeable rotors.
This wiring is the key. It's designed to take an electrical signal from one of 26 input pins
is hardwired to emerge from the output pin corresponding to the letter G. One letter has been successfully scrambled. It follows its own predetermined route, exiting at the pin for E. Each of the 26 inputs has one, and only one, corresponding output. For instance, the letter B. Each signal passes through all 3, and each rotor performs its own separate substitution cipher. Its job is simple, yet brilliant. It takes the incoming signal and sends it back on a completely different path through the rotor assembly. On its return journey, the signal passes back through the rotors, but along a different internal pathway. Each rotor applies a new substitution, further obscuring the original letter. After passing through the final rotor, the letter's transformation is complete.
This characteristic, while a cryptographic strength, would also become a critical weakness exploited by code breakers.
But the machine's complexity'd end with a single static path.
The core of the Enigma's encryption lies in these rotors. As a key is pressed, the rightmost rotor advances. With each keystroke, a pawl pushes against this ratchet, advancing the rotor one position forward. This is the fundamental step. One key press, one click forward for the rightmost rotor. Once per revolution, as this notch aligns, it engages the mechanism for the next rotor in the series.
Each of the 3 rotors has 26 possible starting positions. This alone provides over 17,000 combinations.
But the true cryptographic strength comes from this stepping motion, which changes the substitution with every single key press. When the middle rotor completes a full revolution, it engages the leftmost rotor. This is the odometer effect in action. The answer lay in a shared secret, distributed in advance: the daily key settings. Following the key, the operator would first open the machine and arrange the rotors in the specified sequence. Rotor 2 is placed in the first slot, Rotor 1 in the second, and Rotor 3 in the third. In this case, A, B, C. With the rotors configured, the internal state of the machine is now set for the day.